Hi everybody and welcome. Clover and I are coming at you today from the wonderful recording studio here at my house to bring in a lesson about cones. So after watching today's video, pretty similar to the other shapes honestly that we've done this unit, we're going to be calculating the area of the base, the lateral area, the total area, and the volume of cones. Pretty similar to pyramids, some slight differences that lead us to having new lesson on this that should clear some stuff up and hopefully give us a little bit of extra practice for some of these kind of same concepts that we've been working on quite a bit. So first, what is a cone? A cone is a shape with a circular base. Let's see if it'll let me write here. Sorry about that. This should help. All right, so let's try that again. So a cone is a shape with a circular base that is joined to a vertex by a curved side. This is just a fancy way of saying the bottom of our cone is a circle and it comes together to a point. So how do we find the base area of a cone? Well, pretty similar to shapes that we've been working on here, just the area of the circle that's on the bottom. So in this case, we have pi times r squared, and that's going to help us out. So we do need to know what is the difference between a radius and a diameter. So just a quick recap here. That is a radius. Fully across is a diameter. And as long as we can identify that, we'll be able to find our base area of this cone. All right, so with that being said, let's get started with some examples of finding the base area. Let me pull that up on the next screen here. So 3 different examples, and hopefully these will help us kind of get to that point that we are looking for. So first things first, start with number 1. We have our radius identified here as 3, so pi times r squared is going to get us a base area of 9 pi. So we just take our radius and we square it. Keep going with our next one. All the way across here is 12, so that's our diameter. So to find the radius, we divide 12 by 2 to get 6. So here, pi times 6 squared is going to get us 36 pi centimeters squared for that base area. For our next one, luckily we do have radius. So once more we can do pi times that radius of 4 squared, and that'll get us 16 pi feet squared as our base area. So basically for the base area, we're just doing a whole bunch of finding the area of some circles. So there's our circle base, there's our circle base, there's our circle base, and again, getting to those final answers. So once we've done this, we move on next to lateral area. This is slightly more in depth, a little bit more calculating needed here, a few more basic concepts that we need to find. So the lateral area of a cone, we can define it using the following formula. So it is pi times the radius times L. So R stands for radius, and in this case, L, just like yesterday's video, stands for the length of our slant. Or if we start on the bottom of our base and we bring it to the vertex, that length from base to vertex gives us the slant. So again, not the height. The height is here going straight up and straight down. The slant is me leaning against the wall. It's not how tall I am, it's my length as I'm leaning. All right, so let's get started here. The first one does give us that slant, so we are in luck. So we can do pi r slant, pi times 3 times 5 to get us 15 pi. For our next one, they give us the diameter. So again, the radius of this one is 6. So for our lateral area, pi times r times slant, pi times 6 times 10. So we have 60 pi centimeters squared for that lateral area. For our last one, we don't have our slant. So what can we do? Well, in this case, we have a triangle. We need our slant, which is the edge length here. They give us the radius, and we don't know the height either, but that's okay. So we can actually use this triangle and do a little bit of trigonometry. So again, the bottom is 4. This angle is 60 degrees, and we're trying to solve for x. So if this is our home base angle, that's our hypotenuse. This is our adjacent side. So what we are actually able to do in this case is set up a trig function. So we can do the cosine of 60 equals 4 over x. We'll put cosine over 1 and do some cross multiplication. So 4 equals x times the cosine of 60. Divide both sides by cosine of 60. And we'll get x equals 4 divided by the cosine of 60. So punch that into our calculators here. And that should give us an answer of 8. So what that tells us is x equals 8, which means this length here, this slant, is 8. So nicely, we have solved for our slant. So pi times r times slant, pi times 4 times our slant length of 8. So we end up with 32 pi feet squared as our lateral area. So next, moving on to our total area, very similar to what we have done in the past. Once more, total area equals our base area plus our lateral area. So we can go back to these same example questions and see what we've done so far. So for our first one, we had a base area of 9 and a lateral area of 15. For our second one, we had a base area of 36 and a lateral area of 60. And for our last one, we had 16 and 32. So what we want to do here is one step at a time, put these together. So base area of the first one was 9 pi, lateral area was 15 pi, so our total area is equal to 24 pi centimeters squared. For our next one, total area is again base plus lateral, so 36 pi plus 60 pi, or in this case a total area of 96 pi square centimeters. And for our last one, our base was 16 pi, our lateral was 32 pi, so we ended up with a total area of 48 pi feet squared. So again, kind of the same procedure. I like total area because you basically have already done all the work at that point, so it's just time to take your edges and add it to your base, and once you do that, you have everything that you need. All right, finally, finishing up with the volume of a cone. The formula that we need for this is volume equals 1/3 the area of the base times the height. So capital B is area of the base, and then h is the height. Now be careful, this is the slant, and this here is the height. So that makes your life a little bit more challenging, to be honest, because once again, we are going to need to break out into some right triangles. So if we take our first diagram here, we know this side is 3, we know this side is 5, and our height is x. So in this case, if we're missing just a side length, we can use Pythagorean Theorem. So 3 squared plus x squared equals our hypotenuse, or 5 squared. Again, this has to be c here because it's the hypotenuse, or the longest side length. So 9 plus x squared equals 25. If we subtract 9 from both sides, we'll get x squared equals 16, or x equals 4. So in this case, we have solved for our height of x equals 4. So what that allows us to do is to take the area of our base. So pi times r squared is our base area. So 9 pi. We take that and then we multiply it by the height. So for our volume, we'll have 1/3 times 9 pi times our height, which we solve for, which is 4. So if we just take those, punch them into the calculator, we should get 12 pi centimeters cubed as our final answer. So 9 times 4 divided by 3, or 36 divided by 3 to get us 12. So that's the trick for these, and that's what makes these honestly just a little bit harder, is that we do have to break each of these out into a triangle before we can solve. So I'll do the next two examples a little bit quicker. Same idea though, we can go through and we can get these answers. So for our next one, our radius is 6 and our slant height is 10. So again, 12 is the diameter, but if we cut it in half, that's how we get the 6 right here. And once more, we're solving for our height. So we can take x squared plus 6 squared to equal 10 squared, or x squared plus 36 to equal 100, x squared equals 64, or x equals 8. So our height in this case is 8. So why that's important is it lets us, again, find the area of the base, pi times r squared, or pi times 6 squared. So area of the base is 36 pi. And we can now plug this into our volume formula. So 1/3 times 36 pi times 8, which is our height. So just punch those into the calculator now. So 36 times 8, divide that by 3, and we'll get our volume here of 96 pi cubic centimeters. All right, for our last one, remember from our previous question that we had actually solved for our slant height. We identified the slant as 8. So once more, jumping in here, we have 8, we have 4, and we need to solve for x. So some more Pythagorean Theorem practice. So 4 squared plus x squared equals 8 squared. 16 plus x squared equals 64. So we'll take and subtract 16 from both sides. Get an answer of x squared equals 48. And in this case, if we take the square root of 48, that'll give us x. X equals 6.93. So that is our height. So area of our base is pi times r squared. And then we can plug this into our volume formula. And then plug in our height as well. So we'll have 6.93 times 16 divided by 3. Our volume equals 36.95 pi cubic feet. So hopefully the extra examples today help. I added in that third piece, and again, the hope for that is to see it one more time is hopefully going to be something that's beneficial for us. So again, the volume is a little bit trickier because we do need to break it out into a triangle. That's going to be the only way that we can solve for the straight up and straight down height. Be careful not to confuse slant, or that leaning side, as how tall it is straight up and straight down, because again, it's leaning, it's not standing straight up and straight down. So if you use these skills, if you can break it into a triangle, you'll be in good shape. You'll be able to plug into your formula, solve, get everything that you need to get.